Hello, Chem 2, and welcome to another video from Chapter 1. Sorry for my lack of plaid attire. I'm trying to get this PowerPoint done. It's on Tuesday, our first day of school, and would like to get the video available for you guys at the end of the week. So, sorry, didn't get dressed up. My bad. It's a Chemathon shirt. Does that count? Anyway, so here we go. So section 1.3 is about properties of substances. And this is going to be a nice mix between properties of compounds and properties of substances in general, and a little bit of math. So that's why this section was brought together. This is chapter 1, still matter and measurements. This is the last section of chapter 1. You see, we've done matter in its classifications. We did that very long 2 videos on measurements. Now we're going to do properties of substances. Taking care of the first 4 concepts. Now we're going to talk about density and using it mathematically to relate mass and volume. And we're going to look at solubility and relate the mass of the solute to the mass of a solvent. And again, a mathematical concept using ways of doing conversions and the like. So let's see what we have here. So there's a couple different properties of substances. There are intensive and extensive properties. Your book talks about it. It kind of spends a little bit too much time on it, but intensive properties are things that are independent of the amount. For instance, the color, the density, the temperature, they're all independent of the amount. Extensive properties are ones that are dependent of an amount, and the ones that are classically used are mass and volume. Irony, mass is extensive, volume is extensive, but mass divided by volume is intensive. They also talk about, from Chem 1, you talk about chemical properties and physical properties. The difference is that when you test for a chemical property, the substance could change chemical characteristics and change into a new substance. So 2 of them that they use very often are melting point and boiling point are physical properties, because in order to melt something or boil something, you do not have to change the chemical substance. When you melt ice from solid ice to liquid ice, it stays as H2O. Let me move my phase over here. Maybe I'll put myself up here or over this way. There we go. That way you can see the stuff at the bottom and you see how badly the editing happens, how well it dictates my terms. Anyway, moving on. There's gold. It's yellow. It's soft. Yeah. Okay, density. Density is a ratio of mass divided by volume. So M divided by V. It says mass and volume are extensive properties. The ratio is going to be an intensive property because you're looking at always a ratio that's always going to be the same. No matter how big the sample is, the density is going to be the same. When calculating density, gases and liquids, it's very difficult independently to measure the mass and the volume. It's pretty tough. For solids, the weight of the solid for the mass and the volume is used given its dimensions, usually length, width, height. But liquids, obviously, you have to pour into something. Same thing with gases, you have to pour into something. So you have a hard time measuring that volume really, really easily. So let's look at an example. Glycerol is a very viscous liquid used in both the pharmaceutical and food industry as a sweetener, thickener, and a stabilizer. To determine the density of a student takes a 15.0 milliliter sample by pipette into a flask, and the flask initially has a mass of 28.45 grams. The mass of the flask with the glycerol is 47.37 grams. What is the density of glycerol? Well, since we're looking at ratio of mass divided by volume, we have the mass of the empty flask, we have the mass of the flask with the sample, we have the volume of the sample. So in order to determine the density, we're going to have to find the mass and then divide it by the volume. You find the mass of the sample by taking the mass of the flask and the sample, subtracting the flask. So you have 47.37 minus 28.45 for 18.92. And then in order to find the density, you take the mass divided by the volume. Now this mass has 4 sig figs. The volume only has 3 at 15 milliliters. So when you do that math, you find that the density is 1.26 grams per milliliter. Slightly denser than water. And thinking in terms of density, remember, things that have a density greater than water are going to sink. Things that have a density greater than water are going to float. And the irony is if you remember physics at all, like this cube, the mass of the cube below the actual mass of the cube is equal to the volume of water displaced by the bottom. So if you know what the volume was with displaced, you can measure the actual mass of this cube. It's kind of a neat phenomenon. Okay, solubility. That's the other concept that's involved with this particular chapter. Solubility is a process of one substance dissolving into another. It's a very typical concept. It's very easy physical change. The substance itself does not necessarily change in its chemical characteristics as it's being dissolved. We could talk a little bit more about that later on in chapter 4 as to what really does happen. But when you put them together, so for instance, when I dissolve sugar in water, I get sugar water. The sugar is still in there, so I can drive off the water. I can evaporate off the water, and the sugar will still be there. But the resulting sugar water is called a solution. We talked about that in the first section. There are three types of solutions. There's saturated, unsaturated, and supersaturated. In order, saturated means that it's at a maximum amount of material dissolved in. So, for instance, you've all probably, I know I can tell stories, but put sugar into water. And at a certain point, the sugar just does not dissolve anymore. When you've reached that point, the sugar solution is saturated. You can't get any more to dissolve in. Unsaturated is anything below that. When you have an amount of material that's being dissolved, it's called a solute, that is being dissolved in that is less than the maximum amount. That's called an unsaturated solution. And the really weird thing is supersaturated. Supersaturated is when you do kind of sneak the system in. Maybe you warm up the water enough so that more sugar gets in, and then let it cool down a little bit. And when it cools down, you're going to get a little more than normal in there. So let's talk about a situation here. And again, we're talking about the math side of this. Sucrose, that's sugar, is the chemical name for sugar that we eat. It's soluble at 20 degrees C, and there's going to be like 3 questions here. At 20 degrees Celsius, you can get 204 grams into 100 grams of water. That's a lot. Think about it. You can almost get twice the mass of sugar into water or more than twice the mass of sugar as you have the mass of water. That's a lot. And at 100 degrees, boiling water, you can get 487 grams of sugar into 100 grams of water. A solution is prepared by taking 139 grams of sugar and putting it into 33.0 degrees, 0 grams of water at 100 degrees. So obviously that's less. This is 4 times. This is 4 times the 100, almost 5 times the 100. And 5 times the 33 is going to be somewhere around 150-ish. So this is less than saturated. What's the minimum amount of water required to dissolve the sugar at 100 degrees Celsius? So I have 139 grams of sugar. I want to know how much water do I need? What's the minimum amount of water do I need to dissolve the sugar at 100 degrees C? Well, I know the solubility of sugar at 100 degrees C. It's 47 per 100 grams of water. I know that I have 139 grams of sugar. I need to figure out the minimum amount. So if I have 139 grams of sugar, and I know that my ratio is 487 grams of sugar per 100 grams of water, grams of sugar cancel, and I get that I would need only 28.5 grams of water. So like I said, this solution is unsaturated because I had 33 grams of water, so I only needed 28.5. Second question, what's the maximum amount of water that can be dissolved in the 33 grams of water at 100 degrees Celsius? Again, it's that same ratio idea, but this time we're looking at the water. So if I want to figure this out, I'm going to start with the water. Use the same ratio. This is the same exact ratio. There's nothing different there. But now I'm getting it where I can cancel out the grams of water, and I'm going to multiply times 487 over 100, and find that I can get 161 grams of sugar into my water. Okay, so that's using that conversion factor. Now, the tricky part. I take that solution that I originally made, that solution that was made with 139 grams of sugar and 33 grams of water. I take that original solution and I cool it down to 20 degrees Celsius. Now, I know that what's going to happen is some of that sugar is going to fall out of solution because this is almost 4 times the amount of sugar as water, and I'm only going to allow it about 2 times. So I know some of it's going to fall out of solution when I cool it down. The question is, how much of the sugar is going to fall out? Well, I got to find out how much sugar can fit into my 33 grams of water at 20 degrees Celsius. So, how much sucrose will dissolve at 20 degrees Celsius? And then I'm going to compare that to how much I put in, which was the 139. Okay. So, mass of sucrose. My 33 grams of water at the cooler 20 degrees Celsius ratio, I could get dissolve in there. I can dissolve in 67.3 grams of sugar. I dissolved into it initially 139 grams of sugar. So if I subtract the amount that can stay in solution, can still be dissolved, I get 72 grams is going to dissolve. That's how much is going to precipitate out. Okay. So that's a little bit of the use of math and a couple properties. This last section was really a chance to show you how you can use dimensional analysis and how to use conversion factors to solve some problems that involve different physical properties. So just as an aside, that's the end of chapter 1. I'm going to go ahead and your OWL homework is due on Monday, the 14th at 11:55 p.m. Anytime after that, even a minute after that, is going to register as being 50% off. So get that done. You have plenty of time. You're going to have the weekend to take care of it. And Monday, you can ask any questions you need to in class. I'll leave a little bit of time to discuss any concerns you have with the Chapter 1 homework. Until then, I will see you in the next video when we start Chapter 2, the second chapter of our initial unit for Chem 2 of 2020. Have a great day. I'll see you next time. Toodles.